Hello everyone. This video is here to explore a well-known fundamental property of circuitry, Ohm's law. The man who developed Ohm's law was George Simon Ohm, a German physicist and mathematician who worked extensively in the field of electricity. He published a book on his law in 1827 in which he experimented three aspects of electricity: voltage, current, and resistance. We will briefly go over these as they are needed to understand Ohm's law. Voltage can be described as a potential difference or electromotive force. In general, it is the work per charge difference between 2 points, and this pressure causes electrons to move, creating our next property, current. Current is defined as moving charge and is basically the amount of charge that passes through a conductor at a given time. The resistance of any conductor is characterized as the opposition to the current flow, and is caused by things like geometry, temperature, and electrons colliding with each other inside the material. A nice way of visualizing this is shown on the right, where you've got your push, opposition, and flow. The properties just mentioned are also linked by Ohm's law, in which Ohm found through experimentation that current and voltage are related. Ohm found that a current through a device is always directly proportional to the potential difference applied to the device. Ohm also found that there was a constant of proportionality associated with the voltage-current relationship, called resistance. We can perform a simple experiment to derive an expression for Ohm's law to show its validity. If we look at the shown circuit, it has four main components. We have a known voltage source, which can be varied. We have an ammeter, a voltmeter, and an unknown resistor. If we follow the procedure and measure the current and voltage for various different source voltages, a straight line graph can be made. Since this plot is linear, by calculating the gradient of the line, a value for resistance can be found by using the equation of a line and is equal to 2.2 kiloohms. We can see why resistance is independent of the applied potential, since gradient is the same for all values of voltage. Most conductors behave in this manner, and if they follow this pattern, they are called ohmic devices. Now we'll go through a simple example and apply Ohm's law. A 24 volt source EMF is connected in series with a 1.2 kiloohm resistor. Using Ohm's law, calculate the current traveling through a single resistor. In order to solve this question, we need to use the formula shown before: voltage equals current times resistance, or V equals IR. Rearranging this equation, we get I equals V on R. And now we can sub in our knowns. And now we get I equals 24 on 1200. Equating this into our calculators gives 0.02 amps. Thank you for watching.